Okay, remember that somebody had mentioned that why don't we just add 2 to 8 seconds, because when it reached this part where it's 256 above the ground, this was reached at this point at 2 seconds, and then when it went back down at the 8th second, then yes, you're right. We could just add this point where it comes back down again at 2 seconds. You could have analyzed it that way. That should have worked too. Okay, so that's good. That's good. Okay, a particle P moves on the number line shown in part A of the accompanying figure. Okay, it's right here. And then part B shows the position of P as a function of time. When is P moving to the left, moving to the right, or standing still? Now remember that when you have a positive distance, it just gives you the direction. So from the first second, from 0 to 1, it has traveled 2 centimeters. And then from 1 to 2, it was a standstill. Same thing from 3 to 5. But what happens between 2 and 3? That's when it's changed direction. It was at a distance of 2 centimeters up to -2 centimeters in 1 second. It just tells you that it went in the opposite direction from 2 to 3, and also from 5 to 6 it has traveled from -2 centimeters to -4. Okay, so it's like this. Suppose we have a particle. So the first second it has traveled a distance of 2 centimeters to the right. And then remember, it stopped. It stood still from 1 to 2 seconds. And then from 2 to 3 seconds, it went from covered a distance from 2 up to -2. And then it stood still again. While it stood still for 3 to 5 seconds, then it continued going to the left from -4 up to from -2 up to -4 centimeters. So it went all the way up to here. So from its starting position at 0, we see that it's going to the right. So it moved to the right. In what interval? From 0 to 1. Okay, so, or another way of writing that is t between 0 and 1. And then to the left, there are 2 intervals. We have from 2 to 3 and also from 5 to 6. So if you want to write that in inequality form, it's between 2 to 3 and time between 5 and 6. And where is it standing still? What are the intervals where it was stationary? Okay, it's from 1 to 2 and also from 3 to 5. And if you want to write that in inequality notation, that means from 1 to 2 and t between 3 to 5 seconds. Graph the particle's velocity and speed where it's defined. Okay, so what I will do is just go ahead and mark this out from 1, 2, 3, 4, 5, 6. That's your time, t. And now this is the graph of the velocity. So what we will do is just for every interval where this particle is moving, we just take the slope of the path of the distance traveled. So from 0 to 1, it has traveled 2 centimeters. So 2 over 1 gives you a slope of 2, a fixed slope. So they say this is 2. So from here, and then what happens between 1 and 2? between 1 and 2 we have a standstill. So what is the velocity? It's not moving. So the velocity is 0. And then between 2 and 3 there's a change of direction, moving to the left. So its velocity will have to be negative. So what is the slope of this line? Starting from 2 going to negative 2, that has traveled that has change in y would be negative 4 and then over 1. So say this is negative 2 and that's negative 4. So here you have from 2 to 3 the velocity is negative 4. And then what happens between 3 and 5? You have a standstill again, so the velocity is 0 from 3 to 5. And then what happens between 5 and 6? What is the change? Change in y over change in x, or change in t. Okay, it has a displacement of 2 centimeters, and then it's in the opposite direction. It's going to the left, so it's negative 2 from 5 to 6. Okay, let's mark that. That's 1, 2, 3, 4, 5, 6. What is the difference between the velocity and the speed? Anything that's negative, you just bring it up to positive. So 1, 2, 3, 4, 5, 6. That stays the same because the absolute value. Okay, we can cover that because it's an endpoint. And then the absolute value of 0 is still 0. The absolute value of negative 4 is positive 4. And then from 3 to 5, 0 speed. Then from 5 to 6, the speed is positive 2. So there we have seen that this is the graph of the velocity, this is the graph of the speed. Let me just write it as speed so you won't confuse it as s of t. So there's your speed, which is just the absolute value of the velocity graph, the graph of the velocity. Okay, summary of motion along a line. We have the displacement, the velocity, speed, acceleration, and jerk. So suppose that an object is moving along a horizontal or vertical line, so that its position s on that line is a function of time. Then we have a displacement would be the change in s, average below. Okay, so let's write that down. So displacement would be the change in s. Average velocity is the change in s over the change in time. What is the instantaneous velocity, or just velocity at just one particular time? Then that becomes s prime. Or that's also referred to as v of t. S prime of t is the same as the velocity function. And what is the speed? It's just the absolute value of v of t, or that's the same as the absolute value of the first derivative. Acceleration is the second derivative of t, or that's the same as the first derivative of the velocity function. And then jerk is just the first derivative of the acceleration, so that's equal to third derivative, or that's the second derivative of the velocity. What is the unit of measure here? This would be feet or meters or distance. This is meters per second. This is same meters per second or feet per second or miles per hour. Here it's the same thing. It's just you just always have a positive value. This one is feet per second squared or miles per hour squared. And then of course when you have a jerk, it'll be feet per second cube or feet per meters, feet per hour cube, and so on, or it's just a distance over t cubed because of the third derivative with respect to t.